So I just want to give you a little hint of what my current idea or understanding is. In order to understand the movement of particles, we're talking about particulate organic matter, I actually use a computer-based model to simulate the currents in this area, and you can also predict the pathway of particles. You can also make the particles sink, okay, at different rates. This is the area here that we're talking about, and the area where the orcas accumulate is indicated here, where the red line is. Okay? So what I did is I actually run this model, and I deploy floats, many floats, several thousand of floats in greater depths of the canyons. Okay? So this is the Hood Canyon here in this area. And then what the model indicates is that the canyon that you see here on the left side, okay, this is the entrance canyon. Here, this area here actually operates like a bottleneck for particles. Okay, so what happens is that the Flinders current that exists at this depth moves particles, and there's also upwelling of particles, and moves them through this area where the orcas feed. Okay? You can also look at side views of these simulations. You can see the vertical range here. It's deeper than 1.5 kilometers. This is where these particles are released, and the model indicates that there's an upwelling of particles, and then it moves to the west. Okay, and if you cut across the slope, you can also see the upwelling from 1.5 kilometers to about 500 meters. This is where they end up, the particles, and then presumably supporting or feeding squid, large numbers of squid. And squid are vertically migrating species, and then the whales just come and eat the ones that are just at that in the shallower water. So that's the idea, and it's all to do with the spatial concentration of nutrients. And this is very fascinating stuff. I hope that it's not over the top, so that you gain a little bit of an understanding of how particle-driven, how spatially concentrated food webs work in the oceans.